All right, hey guys, it's Miss Beckham. I am out today, and so I am recording a video for y'all to get you started on some more practice work for stoichiometry. So to follow along with me, you all need to get out the notes that we went through yesterday on stoichiometry. And there also was a second piece of paper called stoichiometry homework number 1, and you need to get that out as well. Okay, so get out both of those pieces of paper. All right. So we went through the notes on stoichiometry. We went through this first page together. That page was almost so easy that it confused some of y'all, if you remember. So we're not going to go through that right now again. Hold on, it's not really letting me scroll. Okay, and then we got through just a couple of these problems here. And so before we do some more problems together, I'm going to rehash the mole map that we made all together, and I'm just going to rewrite it over here and talk about it. So if I were you, I would make a mole map in your journal or on a piece of paper somewhere that you're not going to lose, because you're going to refer to it so much that the more you write it down, the more you're going to be able to memorize it. Okay, so the mole map, basically we learned today or yesterday how to use a mole ratio. So for example, if you have moles of one substance like A, and we ask, well, if you have moles of A, how many moles of B do you have? You can actually convert between moles of A and moles of B. And I want you to think about what you would do to convert between those things. Let's say that you've got, like, hydrogen and oxygen, and it makes water. I'm going to go ahead and balance it like this. Okay. So, and let's say that you've got like moles of H2O, moles of hydrogen. Let's say that you have 4 moles of hydrogen, and you want to know how many moles of how many moles of H2O would you have, right? How would you get from moles of A to moles of B, right? That's kind of what we're talking about. And to get from moles of A to moles of B, what you would use right here is the mole ratio. Okay, and what you would add on, that is the coefficients from the balanced equation. So you have to have an equation for this step. You have to have an equation. If you do not have an equation, then you have to write it based on the word problem. You cannot do this without first writing an equation like this, and they will either give it to you or make you write it out based on like the word problem. Okay. So if you're going from moles of A to moles of B, you would use a mole ratio, okay? So in the example that I just said, if you had 4 moles of H2, and this was your problem here, this is not one in your notes, but you can just pay attention. And you want to get to moles of H2O, you can go straight there. We would want moles of H2 to cancel out, that goes on bottom. And then when you have moles on top and moles on bottom, you use the coefficients in the equation. So when you look here, I have 2 moles of H2O because this has a 2 right here, right? And I have 2 moles of H2. So 4 times 2 over 2 is just 4. So basically what that means is that if I put in 4 moles of hydrogen gas, I will get out 4 moles of H2O. And that makes sense based on kind of that mole ratio there, right? So I'm going to erase all this extra stuff. I'm just trying to do this, an example with it. So I'm going to erase that. I'll leave that up there though. Okay, so that is the main thing that we learned. We also learned that you can go from moles of B to grams of your B. Grams of B, right? And we already knew how to do this. When you go from moles to grams, what do you use? Molar mass, right? You use molar mass. And if you want to be more specific, if you're going from moles of B to grams of B, you're going from moles to grams. Grams would be on top, right? Because that's what you're trying to get to. And your moles of B would be on bottom. So basically in this step, the simplified way of saying that is that you're going to multiply by the molar mass, right? Because you're going 2 grams. Another situation to make it a little bit harder is if they might give you grams of your starting substance rather than moles. So if your starting substance is moles, then you're already set and you don't have to do any preliminary step. But if they give you at the very beginning grams of A, then you would have to get to moles of A first. And again, you would use molar mass, right? But this time we're trying to get 2 moles. So if you want to add this onto your mole map, I don't know if every period specified this. I think first period, I did not specify this part. So I would add this on, especially here. If you're trying to get, like on this step, you're going from grams to moles, that means that your grams are going to be on bottom and your moles are going to be on top, right? So a simplified way of saying that is that in this step, you would be dividing by the molar mass if you're going from grams to moles. And then in this step right here, moles to grams, you would be multiplying by the molar mass. That's a simplified way of saying it. And then this mole ratio in the middle, if you want to be really specific, the moles of B with the coefficient would be on top. And the moles of A with the coefficient, whatever that is, would be on the bottom. Okay, so we're going to refer to that when we do some more of these problems here. So I'm going to work a couple of these problems with y'all now. Most of my class for every period finished at least a couple of these here. So if you, depending on each class, they may have been one problem off from one another on what we completed on this page here, but go to this page. I think it's the first page of your notes because they're kind of in a weird order. Let's do the one on sodium chloride right here, when sodium chloride reacts with silver nitrate. Okay, so as soon as you read that problem, you should notice that you don't have an equation. So we need to write the equation. Okay, so I want the substitute to pause this video and let students have a couple minutes to write the equation out in small writing, maybe here or off to the side somewhere, as small as you can. Write the equation, probably like right here in this space right here. Okay, so go ahead and pause the video. All right, so let's go ahead and do it together. Hopefully y'all have practiced this on your own first or tried it. So let me highlight what looks like it's important to me. Sodium chloride reacts with silver nitrate. Sliver chloride, okay, sliver chloride, I think you mean silver chloride, but silver chloride precipitates. What mass of silver chloride is produced? So we need the formula. So sodium chloride is, I'll zoom in because I want y'all to be able to see this, is Na, the +1 charge, and Cl with a -1 charge. So +1 and -1, that cancels out, right? All right, and then reacts with silver nitrate. Silver always has a +1 charge. Nitrate is NO3 with a -1 charge. So those also are going to cancel out. And they react. So what type of reaction is this? We have 2 compounds. So this is going to be a double replacement reaction. They're going to swap partners. So our final product would be AgCl. And it said that silver chloride precipitates. But you also don't want to forget, it doesn't tell you in the word problem, but it's insinuated because this is double replacement. So what is the other product going to be? It's going to be NaNO3, and it's +1 and -1, and so they also cancel out. Okay, and this is already balanced. Thankfully, we don't have to do any sort of balancing. It's already balanced for us. Okay, so now we're going to read it and highlight what we're starting with. Okay, so in this problem, we are starting with 75 grams of silver nitrate. Right? And we're trying, there's really not enough space in this problem. I'm sorry, y'all. I would grab another sheet of paper and do it there and staple it to the back so that it stays organized because this is just not enough room. So 75 grams of silver nitrate, and we're trying to get to grams of silver chloride. Do you see that? Because it says what mass of silver chloride is produced. Okay. Okay, so we're starting with grams of AgNO3. So do you see how that is our A? Basically, whatever you're starting with is your A. And this is our B, right? So when we're on our mole map, we're trying to get from grams of A, right here. We are right here. All the way over to grams of B, right here. Okay? So we need to get from grams of A to moles of A. Okay? That's our first step. Then we'll use the mole ratio to get from moles of A to moles of B. And then we'll use molar mass to get from moles of B to grams of B. So your mole map should be your route for this, okay? So now I'm gonna like just erase a little bit and start over here. So I'm gonna real quick get the molar mass, or basically I'm gonna multiply. And what I first want to get to is moles of A. And our A is AgNO3, right? That's our first substance. And I want this to cancel out. So I'm going to put that on bottom. Okay. So where do I get this information? Where do I get the relationship between moles and grams? Well, I get that from the periodic table, right? So when you go from moles to grams, use your periodic table and add up and get the molar mass of AgNO3. Okay. So doing that quickly, which you should add up silver, nitrogen, and 3 oxygens, you should get about 169.87. Depending on the period, some periods don't care as much about this. Do not freak out if your decimals are a little bit different than that. It's because I did it quickly and I used a periodic table on my computer, and that might be slightly different in how they round their numbers than the one that you use. So if you get like 169 or close to that, you probably did it right. Okay, so don't freak out. Next thing we got from grams, see how that cancels out? Okay, so I'm gonna do red here and cancel out. So now what do I need to do? Now I need to get to moles of B. So what am I trying to get to here? Silver chloride, right? What mass of silver chloride? So next I'm gonna get to moles of silver chloride, and I need moles of AgNO3 to cancel out. So do you see how I have double moles happening here? So if you remember how to get those numbers, think about where we're going to get those numbers. We're going to get that from the equation, right? So it looks like I have right here, how many moles of AgCl do I have? 1. How many moles of AgNO3 do I have? 1, right? 1 of each. Okay, and I got that from my reaction, but they both happen to have like an invisible coefficient in front. And we're close. We got to moles of silver chloride, but the problem said what mass of silver chloride. So I need to go one step further and get to grams of silver chloride, and I need my moles of silver chloride to cancel out. So how do I fill in the relationship between grams and moles of silver chloride? The molar mass, right? You're going to look up on the periodic table the molar mass of silver chloride. And when you add that up, you should get something close to 143.32. And then you're going to calculate. Put all of that in your calculator. And I am getting 63.28. And I will change the significant digits in just a second. Let me just double check that that is what I want. Yeah, 63 point, yeah. Okay, so, and then we're going to round that off because 75.0 right here has 3 digits in it, right? 75.0. So we're going to make this 63.3 grams of AgCl. So this was an example of the longest situation. We didn't do this yesterday. We started with grams, and we're getting all the way over to grams. And if it seems overwhelming for you right now, it will get easier with time. And I'm going to have y'all watch videos after this again. So this next problem I'm going to have y'all do on your own, but I'm going to highlight what looks important to me. Thankfully, it's already written it out for you. And it looks like we're starting with 105.5 grams, and we're trying to get to moles of carbon dioxide. So my A is methane. That's what I'm starting with. And my B is carbon dioxide. And I'm trying to get to moles of B, not grams of B. So see, on the previous step, we had to get all the way over to grams. We can mark out this step for this next problem because it only wants moles. So you're going to use your mole map to get all the way from grams of it to moles of it. I mean, grams of methane to moles of carbon dioxide. Okay. You know what? I'm actually going to do this one with y'all just because I feel like it'd be helpful to have one more example problem done with y'all. So let's go ahead and write this up. Thankfully, the equation is already written for us. So we're starting with 105.5 grams of methane, which is CH4. It tells us in the problem, right? And that's like our A, right? So flip to your mole map. Everybody get your mole map, flip to it. Put your finger on where we're starting. Okay. You're either starting on grams of A or moles of A because A is like whatever you're starting with, right? So whatever chemical you're starting with. So in our situation, we are starting right here. X marks the spot, right on grams of A, right? And we are trying to get all the way over to moles of B, right? Moles of a different substance. So when you look at your mole map, what steps do you need to take? What steps do you need to take? Well, we need to get from grams of A to moles of A to moles of B, right? From grams of A to moles of A to moles of B. So I'm going to write that in up here. Grams of that to moles of CH4. And then we can get to moles of carbon dioxide, right? And if you even want to write in like what you would use for that, you know, you'd use molar mass here and the mole ratio here. You could write that out. So let's go ahead and do it. I'm just going to write real small right here on it. This is what I'm starting with. I'm going to do times. And we need to put what I want to get to on top. So we know that we want moles of CH4 on top. And I want on bottom whatever this is, which is grams of CH4. So where would I get the relationship between moles and grams? Where do I get those numbers from? The periodic table, right? We're going to get the molar mass. So when I add that up, I'm getting 16.05. That number always goes with the grams. And the number 1 goes with the mole. So you should be filling this in. And now I need to get to moles of CO2. So what should go on bottom here? This is already canceled out, right? So moles of CH4 should go on bottom, right? Now I've got moles on top and moles on bottom. So I need to use the equation for this step. And it looks like I haven't balanced it yet. Do you notice how it's not balanced? So I'm going to go ahead and go in and balance it. My C's are balanced, but I have 4 H's here and only 2 over there. So I'm going to put a 2 here. And now I'm going to add up my O's. I've got 2 O's right here and 2 O's here. That makes 4 O's on this side. So I'm going to put a 2 right here to get that to 4. So now I've balanced my formula. So now I have moles and moles. How many moles of CO2 do I have right here? 1. And how many moles of CH4 do I have? Just 1. Okay, so that's that. My moles of CH4 will cancel out. Okay, so now I just need to calculate. And I'm getting 6.573 moles of CO2. And my significant digits are matching there, 105.5 and 6.573. Okay. All right, next one. Chlorine gas is we're on the next page now. Chlorine gas is reacted with potassium bromide to produce potassium chloride and bromine gas. So pause the video, write the formula for that in your right here, and then push play whenever, after about a few minutes have passed and most people have finished it. All right, so chlorine gas is Cl2 because have no fear of ice cold root beer, it's doubled, is reacted with potassium bromide +1 -1, so they cancel out, to produce potassium chloride. We recross over +1 -1, they cancel out, and bromine gas. This is root beer, right? So this is also doubled. So this is our formula here. It's not balanced yet, right? So we need to go back in and balance it by putting a 2 here and a 2 there. And now we have our balanced equation. Okay, so here's a fun one. It says how many molecules of bromine will be produced from 312 grams of KBr. So we're starting with 312 grams of KBr, right? And we're trying to get to molecules of bromine, which is like a whole different substance, right? So let's go to our mole map. We're starting with grams of A, right? But we're not trying to get to grams of B here, are we? We're trying to get to particles. How many particles? So we should remember kind of how to do this. We're going to go from grams of A to moles of A to moles of B. But right when we get here, we're going to shoot off and we're going to use Avogadro's number to get to particles of B. Particles of B. If you want to add that on, and we're going to use 6.02 times 10 to the 23rd to get to that step. So we're going to kind of shoot off of our normal map here because it's asking for particles or molecules. It's not going to ask for these as much, but the steps are very important for you to know how to do them. Okay, so first we're going to go from grams of A on our mole map to moles of A. So we're going to divide by the molar mass of KBr. We're trying to get to moles of it first. So the molar mass of it should go on the bottom. You should get that from the periodic table. And when you add those two up, you should get about 119.0 grams. It might be slightly different on your periodic table. Okay, that gets us to moles of KBr. We're trying to get to molecules of bromine. So we need to use the mole ratio to convert to bromine, not KBr. So bromine needs to be on top and KBr needs to be on bottom, and we need to put in this relationship here. So bromine has 1 based on the coefficient, and KBr has 2 based on the coefficient, right? Now we've got to moles of KBr, which were really close, but it asked for molecules. Well, how many molecules are in a mole? Always 6.02. Okay, so now you're going to just put that in your calculator. Everybody should do this to make sure that you're all understanding how to put this in correctly, because it's always terrible when everybody does it right on the test, but then you just calculate it wrong and you still get some points off for that. So I should expect this to have a big number because it asked us for how many molecules, right? There should be a ton of molecules. I'm getting 7.89 times 10 to the 23rd molecules of Br. Okay, so that's that type with, like, you know, using molecules instead. We're going to skip gas stoichiometry. And so these are really your main notes for today. I think that y'all have gone through, we've gone through all of the notes now for stoichiometry. The most important thing is learning how to use your mole map. And so with that, I want to start you guys off on your homework set. For the rest of the class period, you're going to work on homework set number 1. This is homework set number 1. This was given to you yesterday on Thursday. You're just going to complete all of these using your mole map. So if you notice, homework number 1 is just moles to moles. You're going straight from moles over to moles. It kind of breaks it up for you. Part 2 is moles to mass. Part 3 is mass to moles. And I think that's it. We don't have you do mass to mass on these. So the mass to mass, the ones with like 3 steps in it, are not on this homework set. Okay, which is kind of nice for y'all. So you obviously need to balance your equations first if they're not balanced. I think y'all can all do number 1 on your own. You're going straight from moles to moles using the mole ratio. You're going to do those. Mole to mass. I might just write out for y'all, like on your mole map, what you're doing there. So if you want to just write this in this gray part for notes for yourself, you can. Hold on. You're doing moles of A to moles of B to mass of B, right? And you need to fill in, you know, after that, how to do it, okay? In this one, you're starting with mass of A, going to moles of A. You should be writing this down as notes for yourself, to moles of B. Remember, A is just the chemical you're starting with, and B is the chemical you're trying to get to. That's what we're distinguishing there. And that's what you're going to work on today. You're going to do this worksheet. And if you want, like, you can ask Miss Hollis for help next door over. She's in room 306, and she can help you. If you ask permission to specifically message me on Remind, you can do that. Yeah, and I want to see when I come back on Monday who got their answers right and all of that. I want to see who did it on their own. I'm going to be super proud of you guys if you can finish this today and have it turned in and let me see your work on Monday. So this is a homework assignment. You're starting it on Friday, so you're technically going to turn it in by Tuesday. Okay, and as a reminder, some people have not turned in their solubility lab. That was due on Wednesday of this week. So make sure that you turn in your solubility lab if you have not done so yet. And ask Miss Hollis in room 306. Actually, I think it's 305. It's the room with that fan in it because the AC has been out. Her name's Miss Hollis. Ask her for help if you need help with anything. And other than that, I hope you'll have a great day. See y'all on Monday.